here today we have a job to do to estimate existing safety of electrical substation, its surrounding fences and pylons, to evaluate safety for design of new solar power plant, which will be situated here in this field. For that purpose, we have in our car generator, and we will first establish the voltage funnel. We will measure step and touch voltages in surrounding and also the grounding resistances of this platform. Let's go. Here we have measurement system, generator, we have some voltmeters with different functions, additional flexible current clamps. We will use it later. But first we need to prepare generator. Generator is ready for later use. Now we need to prepare everything to connect the voltage funnel. We have additional tester also for some analysis if we will need it later. But what we have it here, we have reels with cables. One reel is approximately 300 meters of cable, and 600 meters shall be enough for the substation in a cross section 100 times 50 meters. This is one part. We will connect also the rods to ground on this side. We will use also hammer on this side. One part of the generator will be connected to the pylon, which is down there. We will use G-clamp to connect wire to the metal part. And this wire will be connected to this side. Voltage funnel, touch and step voltages will be measured by those voltmeters. We have also some flex clamp for split factor evaluation, and those plates will be used to connect the contact, to establish good contact to the ground. Here is the end of the first reel, and we will connect another 300 meters. We will go in this direction. The colleague will drive this wire further on. we finish with positioning of test rods, and now we will connect rods to the reels wire. For that purpose we need the electric gloves to protect ourselves, to protect possible transfer of voltage or current that can be hazardous or risk. And now we will connect all the parts and go back to the generator.
Outdated method encompasses a heavy, barely mobile generator with an unsafe 400 volt output and a low resolution voltmeter. Our new approach is based on an easy-to-carry generator and a remote, highly accurate autonomous voltmeter with resolution down to 1 microvolt. What do you think? Which method is better?
Well, we have generator running. We will measure the voltage potential between the substation and the surrounding. For that purpose we will use this probe and this voltmeter. The voltmeter will serve us for measuring the difference between the substation and potential on the field. We need to measure it several times for fall of potential, to establish where is the flat part of the S-curve of this voltage tuner. Now in the second stage of the measurements, we will use step and touch method. We still need the electric gloves because you never know what can go wrong. We will use the touch plates, which are 200 square centimeters, and we will step on it to simulate 50 kilos for the body simulation. Additionally, we will measure the split factor of this pylon. For this purpose, we have the flexible clamps to connect around each leg. So the first measurement would be the current measurement of the separate leg. So first we connect the flex clamp and we measure the current, which is very close to 10 milliamps. The complete current to the tower is, we can check. So we remove the flex clamps to the input circuit, and we can see that total current is around 876 milliamps. It is stable current. And now we can again measure separate leg to establish where this current flows. Out from those results, we will also get the information about the split factor of this tower. So actually, you can see the current now is 11 milliamps, very small according to the whole current flowing into the system. We will move now to all 4 legs, so from this part to another, to establish the complete split factor of this tower. Now we have the results of the second leg, which is very close to the previous one, and we can move to further on to next, so to get all 4 results. Well, we finished with all 4 legs. The results were about 10 milliamps each, what means 40 milliamps for the legs. And now we can calculate the step and voltages, which we will measure with the next procedure, with the next measuring method. And we can prepare this for. First we will measure touch voltages. We will use plates for the step on, and we need to interconnect them in between. One part of the voltmeter will be connected to those plates. We will use the same voltmeter as before for testing current. Now the current clamps are not needed anymore. And the other part of the voltmeter will be connected to the tower itself. For the purpose of testing, we need to prepare the instrument with some parameters to adjust. So we will put the set current, the current which flows to the pylon now from all 4 legs, 40 milliamps. We will calculate the result to the volt as lightning strike at 50 kiloamps. We will use the body resistance simulation So the input resistance of the voltmeter here is prepared for 1 kilo ohm, which simulates the resistance of a human body, and the limit parameter is set to 710 volts, which is the maximum allowed to lightning strike situation. Okay, start with the measurement. We need to step on the plates first, and we can see the result is between 8 to 10 kilovolts, which is very high for this situation. So we have here quite a dangerous situation in the case of lightning strike, which means that this part of the pylon need to be repaired, need to be adjusted, especially when the solar power plant will be built in this field. We need to redesign the complete groundings of this platform. This was the touch voltage measurement, which is usually the most dangerous or the extreme situation. If somebody is touching the pylon during the storm. The next, we will disconnect from there and we will measure the step voltages further on the page. Well, the last part, measuring of the step contacts in surrounding, is the most time consuming for the measurements. We need to measure all around the pylon in different directions, so 1 meter apart, 2 meters, 3 meters and so on, until we come to the safe area. Here, with these measurements, as we saw here, the results are around 30 volts, which is very safe in this part. Okay, perfect. Yeah, we finished today with our measurements. Thank you for your attention, for watching this video, and see you with next one. Thank you.
Bye.
Now water.